All right, let's go ahead and look at a couple more examples of adding mixed numbers and subtracting them with our regrouping method. Again, in the long run, this method ends up being honestly an easier method than turning it into improper fractions, although you can always turn them into improper fractions. You'll also get the same answer. You'll just have to convert your improper answer into a mixed number at the end, which tends to be a little bit more work, which is why I'm a big fan of this method. So we've got 4 2/3, and to that we're adding 5 2/3. So just like we do with decimals, we're going to go ahead and start all the way to the right with our part of a whole thing. So 2/3 plus 2/3, well, that's a total of 4/3. And 4/3 is the same thing as 1 1/3. Now this is where the regrouping comes into play. I'm going to go ahead and regroup my one whole thing with my ones column, with my whole column. And then I'm going to go ahead and take my fractional piece, and I'm going to bring it down here into my fractional column. 1 plus 4 plus 5 is 10. I've just gotten my answer. Now subtraction again is a little bit tougher, so let's do another subtraction problem together. So we've got 6 2/5 minus 3 4/5. So I'm going to go ahead and start with my fractions. Now I can't take 4/5 from 2/5. I mean, technically I can. I would end up in negative land. However, we don't want to deal with negative integers at the moment, especially considering that I have some whole numbers that I can use to help myself out. So I'm going to go next door and I'm going to borrow a whole number, which will reduce that down to 5. Now when I bring that one whole thing over, I envision this as a crane that's, you know, picking up one whole thing, bringing it over, and we're going to drop it down into fraction land, and the fractions that we're dealing with are fifths. So when I bring this one whole thing over, I'm going to bring it over as 5/5 because those two things are equivalent. So I'm going to go ahead and drop that down. So this problem is the same thing as 5 7/5 minus 3 4/5. Now normally we don't like numbers like this because we've got an improper fraction, and generally we don't love having improper fractions. But this is now helpful for us because now I can indeed take my 4/5 away from my 7/5, and I'm left with 3/5. 5 minus 3 is 2, and I'm done. Let's do one more example of the subtracting, because again, I think the subtraction is a little bit tougher. This is good because this time we have unlike denominators, so we have one extra step here. We need to create common denominators. So we've got 7 1/3 minus 3 4/6. So the first thing I need common denominators. I can do this one of two ways. I could multiply this guy by 2 halves and create sixths, but I'm also noticing I can actually simplify this, which is exactly what I'm going to do. I'm going to go ahead and simplify this, and I do believe it will simplify to thirds, 3 2/3. Okay, so now I'm going to go ahead and tackle this problem. I'm going to look at my fractional pieces first. I'm trying to take 2/3 away from 1/3. I don't have enough thirds to be able to do that. So what I'm going to do is I'm going to take one of these whole things, and again, so we've got one whole thing is comprised of 3/3. So I'm taking just one whole thing, and I'm going to bring it on over here, and I'm going to drop it down as 3/3. So I'm just kind of rearranging my number. I'm still keeping the 1 within this top number, so it's not that I'm losing any value here. I'm simply kind of rearranging it, and I like to think about my numbers as like Play-Doh, how you can kind of mold it and sculpt it into different shapes, but it still is the same thing. It still has the same mass, the same amount of Play-Doh. It's kind of a similar idea. So this number now becomes 6, and let's see, well, what do we got here? 4/3 minus 3 2/3. 4/3 minus 2/3 leaves us with 2/3. 6 minus 3 is 3. That's your answer.